G'day Year 9s, I just thought I'd record a quick little video here to step you through for A and B, linear relations and graphs. I know you've seen this sort of thing before, most of you, so I don't think it'll be too complicated, but this should just help clear up any problems you have when you're trying to do your work this afternoon. The learning intentions up there are what we're going to try and do, but they're going to be summarised by what I teach you underneath, so you can read them if you like. If you're not sure about any at the end, you can always come and ask me about them. So coordinate geometry, dealing with placing coordinates in a plane. Here we have a Cartesian plane named after René Descartes, and it's broken up into 4 quadrants. The first, second, third and fourth is indicated there. X is my horizontal axis, the y coordinates represented by the vertical axis. The origin is at 0, 0, 0 on the x coordinate, and 0 for the y coordinate right there, and it's labelled with an O, as you can see. Any point in that region can be described by an x and a y coordinate. For instance, this point over here, 3, 1, I've gone 3 steps to the right and then 1 up. The coordinate pairs are always expressed in terms of x and then y, because x comes before y alphabetically. I'm pretty sure that's why they were chosen. What we're really interested in are straight line equations at the moment, or linear relations. Linear in maths always means straight lines. And every linear relation, in fact every relation, is just a set of ordered pairs. Linear relation ones are sets of ordered pairs that give a straight line. Intercepts are points where the axis is intersected by a line, and we call that an intercept. So here, for this particular example, the x-intercept is 2. You can see it graphically really easily because it's going through the x-axis at the point 2. The y-intercept is 4. If you're looking at a table of values, here they've got a rule where for every x value, there's the corresponding y value underneath. To find the y-intercept, it always happens when x equals 0. To find the x-intercept, it always happens when y equals 0. And you can see why that's the case. To find the y-intercept, I've got to be on this vertical axis there, which means the x value at that point is 0. Because you can see 0 is there. And it went 1, 2, 3, 4 in that direction, -1 in the other direction. So when x equals 0, I'm able to find the y-intercept. In the same way, when I'm at 0 on the y-axis, here was -1, 0, 1, 2, 3. So 0 on the y-axis at the origin. Then if I go left or right, I'm going to find the x-intercept. So to find an x or y-intercept, you always let the other variable equal 0. And we'll see some examples in a minute. They just tell you the same thing again there. So how interesting that they double up, but reinforcing what we need to do. Using the range of values -3, less than or equal to x, less than or equal to 3, construct a table of values and plot a graph for these linear relations. I know you've done this before, so I'm not going to spend too much time on it. The table of values, you choose the x values and then you calculate the y values. So you calculate for x equals -3, I'm going to go -3 plus 2, well, that'd be -1, and so they wrote the -1 there. When x is -2, I've got -2 plus 2 is 0, so they put the corresponding y coordinate 0 there. And you just go through and do that to fill in a table of values. Once you've got those points, if you put the x and y coordinates on a line, you should see that they join up nicely. When you're doing these in your books, make sure you just use a ruler to keep it fairly neat. It doesn't need to be exact, it's a sketch, not a scale diagram, but just try and keep track of that. If you find that really easy and you know how to do that, just do 1 or 2 of those to practice and then move on to the more challenging questions later on. There's some there for you to try. You can either try those examples there as practice, or you can get straight into the work. It's up to you depending on how you feel you need to go with those, how much practice you need. Here's practice. Remember writing down the x and y-intercept. So the x-intercept happens when y equals 0. So for an x-intercept, I always want to let y equal 0. So I follow along the y coordinates until I see 0. So my x-intercept is equal to 1. My y-intercept always happens when x equals 0. So I let x equal 0. And my y-intercept, in that case, when I go across x equals 0, the y-intercept would be 2. We can do the same for a graph. Here the x-intercept, it's easier to see, isn't it? It's just where it crosses the axis. x-intercept is -4. The y-intercept is 6, where it's crossing the y-axis. Just a little word of caution, sometimes if they ask for the coordinates of the x-intercept or y-intercept, although the x-intercept is 4, if the question asks for the coordinates of the x-intercept, then you need to list the coordinates at that point. So it would be -4 and 0. If I wanted the coordinates of the y-intercept for that same graph that we were just looking at, then if they ask for coordinates, you give them coordinates. When x is 0, y is 6. If they just ask for the intercept, just the number's fine. Nothing too complicated there. To decide if a point is on the line, you simply substitute in the x value and then see if the y value matches. So for this first particular question here, y equals 2x plus 4, I'm going to substitute in x equals -2, which they do. 2 times -2 is -4. -4 plus 10 is 6. This was asking is the point -2, 4 on the line, so it's not on the line because 6 does not match up to the y coordinate of 4. They're not equal to each other. If they're not equal, the point doesn't lie on the line. If I'm looking at the second one, does the point -2, 4 lie on the second line? -2. See how they're substituted in? When you're substituting in a number, use brackets. -2 becomes positive. So that's 2 plus another 2 is 4. They wanted to say is -2, 4 on the line? Yes, it is, because 4 equals the y coordinate for the point that we were given. Again, pretty straightforward stuff. I know you've done that before, so it shouldn't be too bad. Sketching the graphs is the last little thing for today. I'm going to get rid of their things and do it myself because it's going to be more fun for me and for you. Give myself a little bit of room there again, though. Okay, when you're given an equation in this form, it's definitely easiest to sketch by finding the intercepts. If I find the intercepts correctly, hopefully you can read that sketch by finding the, it looks like L, I'll rewrite that word too. Sketch by finding the intercepts. When you're given it in standard form, when you've got ax plus by equals a number at the end, that's the way I want you to do it. When you've got them given in this form, which we will look at later, but this is the gradient point form, or better still, the gradient intercept form. The first value always tells me the gradient, a measure of how steep the line is. The second number always tells me the y-intercept. And that's whenever I have y equals mx plus c. The coefficient of x, that's the gradient. The number at the end, that's the y-intercept, because if I let x equal 0, that whole mx is going to be 0, and then y would be equal to c. How do we go about sketching these? So for the first one, to find the x-intercept, I'm going to say let y equal 0. Therefore, I know that 2x is going to equal 6, because 3 times 0 was 0. When I let y equal 0, that other term is now 0. Therefore, my x-intercept, sometimes I like to write a little subscript there to remind myself that it's the intercept. When I divide each side by 2, I'm going to get the x-intercept equals 3. I can also find the y-intercept. To find the y-intercept, I let x equal 0. Therefore, that first little bit of the equation, 2x is going to be 0, so I'm just going to be left with 3y equals 6. Dividing by 3 on each side, I'm going to get y equals 2, so that's my y-intercept. Once you've got your two intercepts, it's a sketch, so it doesn't need to be super beautiful, but try and do the important things. Label your axes and the origin. The x-intercept was at 3, 1, 2, 3. The y-intercept was at 2, 1, 2. Once you've got your 2 points, you can join them with a straight line, and you're done. I'm even going to take the time to label my equation, but it wasn't y equals, it was 2x plus 3y equals. Do it that way. 2x plus 3y equals 6. So when you give it in that form, ax plus by, use the intercepts to sketch. The second one, where I've been given the gradient and the y-intercept, y equals 2x minus 6, I know my gradient equals 2. Remember, a gradient is a measure of your increase in height, your rise, divided by the horizontal distance, the run. Some people like to think of that as delta y over delta x. Delta is a Greek letter that we use to symbolize a change. You may have seen that in science. So if I wanted to find the change in y-coordinates, it's sort of like saying if I had one y-coordinate, point y2, and I took away another y-coordinate, that would be the difference between them. Change in x is the difference between my x-coordinates. Again, we'll see that later, but it's nice to just see it now if you haven't done that last year. So how do I sketch one when I know the gradient and the intercept? Well, first thing I do is I know the y-intercept. So once I've got my sketch here, got my axes all ready to go. Negative 1, 2, 3, 4, 5, 6. My y-intercept is at negative 6. My gradient is 2, which means the rise divided by the run. I have to go, 2 is the same as 2 over 1, isn't it? It's the same thing. So I've got to go rise by 2 for every 1 that I go across. So I've got another point that it goes through. I could do that again just to make sure. I could go up 2 spaces from there, and then 1 across, up 2 spaces from there, and then 1 across. So you can see that it's actually going to go through those points. They all follow. I could keep going. I can go up 2 and 1 across and keep going. But you only need 2 points to get a straight line. Sometimes it's good to have a third point to make sure, but there's my equation. Y equals 2x minus 6. So it's going up 2 for every 1 it goes across. That's the easy way to sketch those. There's a couple there for you to try, and that should keep you going. Good luck with that. I will see you in our next lesson. You can ask me any questions. Don't forget you can also ask Qbot in Teams any questions. If you're not sure how to do that, if you scroll to the top of the page, it's there and it will tell you what to do. And I think I even put it in your task sheet. All right, good luck today, guys. Let me know if you're having trouble, and I can certainly have a chat to you then. Take care. Bye.